Ladies and gentlemen, we are now going to take a look at 8.3. No guide. How can you find the sum of terms of geometric series? Well, that's what this is all about. Geometric sequence, a sequence where the ratio of any term to the previous term is a constant. So here is an example. Here are the terms in your sequence: 3, 4.5, 6.75, 10.125. Take 4.5 divided by 3, that's 1.5. 6.75 divided by 4.5, 1.5, and so on. If all these are constant, then it is a geometric sequence. Get the same thing. Now let's check and see if this one is. 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is 3. So R equals 3. Yeah, it's geometric. Now let's take a look at this one. 7 divided by 2 is 3.5. 12 divided by 7 is not 3.5. Not geometric. Rule for the geometric series. So coming back, the nth term of geometric sequence with the first term a sub 1 and a common ratio is given by the following. So this should be right down here. A sub n equals a sub 1 times r raised to the n minus 1 power. I don't know why I slid up there, but it's not supposed to be, but there you go. Write a rule for the nth term of sequence and find a sub 6. So first we need to do is figure out what r is. So you got to take one term divided by the previous term. If we do that, we find that r is 4. So we're going to write a rule. A sub n equals 3, that's first term, times the ratio raised to the n minus 1 power. Now we're going to figure out the sixth term. A sub 6 equals 3 times 4 to the 5th power. 6 minus 1 is 5. When you put that in your calculator, you'll get 3,072. That is the sixth term. Okay, let's take a look at the next one. Take your terms divided by the previous term. R equals negative 1/3. A sub n equals 36 times negative 1/3 raised to the n minus 1 power. Okay, let's figure out the sixth term. A sub 6 equals 36 times negative 1/3 raised to the 5th power. So that's going to be negative 36 divided by 340 or 243. Now you know me well enough, I'm going to expect you to reduce that. That reduces to negative 4 over 27. Again, you can use your calculator. One term of geometric sequence is given along with the common ratio. Write the nth term, find a sub 6, and graph the first 5. Okay. So, first thing I need to do is figure out what a sub 1 is. 54 equals a sub 1 times 3. And remember, this is the n minus 1 power. So I'm going to take 5 minus 1, which gives me a 4 right here. So I have 54 equals 81 times a sub 1. Divide both sides by 81. And reduce, and this equals 2/3, is a sub 1. Cool. The next step is I need to figure out what a sub 2, 3, 4, 5, and 6 are. Here's a sub 1. A sub 2 equals 2/3 times 3 raised to the first power. That equals 2. A sub 3 equals 2 times 3 squared. See how that 2 came right here? I'm sorry, I just made a mistake. That's your first term is 2/3. That right there should be 2/3. I apologize. So now we just simplify this. 3 squared is 9. 9 divided by 3 is 6. 9 divided by 3 is 3 times 2 is 6. So a sub 3 is 6. A sub 4, 2/3 times 3 cubed. 27 divided by 3 is 9. 9 times 2 is 18. A sub 5 equals 2/3 times 3 to the 4th. So 3 squared is 80. 3 to the 4th is 81. It's 27, 54. So this here is going to be equal to 54. Now I figure out the last term, which is a sub 6. 2/3 times 3 to the 5th equals, it's 243 divided by 3 is 81 times 2 is 162. Those are my terms. So a sub 1 is 2/3. That's 1. A sub 2 is 2. A sub 3 is 6. A sub 4 is 18. A sub 5 is 54. And then a sub 6 is way up here someplace. Way up there. You do not connect these together because those are individual terms. It's not actual graph. Okay. B, you're going to do the same thing. So again, B, you do the same thing. So we're going to skip over here to the back side. I'm going to write up here the rule again just so we remember as we're working. A sub n equals a sub 1 times r raised to the n minus 1 power. Two terms of the geometric sequence are given. Find the rule for the nth term. Okay, we can do that. A sub 3 is 45. A sub 5 is 505. 405, sorry. 45 equals a sub 1 times r squared. 3 minus 1 is 2. So 45 over r squared equals a sub 1. So as you can see, the first thing we want to do is we want to figure out what a sub 1 is. I'm going to do the same thing with this term. 45 equals a sub 1 times r raised to the 4th power. Notice a sub 1 is 45 over r squared. So 405 equals 45 over r squared times r to the 4th. 405 equals 45 times r squared. So I'm going to divide both sides by 45. 9 equals r squared. R equals 3. We're only looking for the positive the principal roots here, not both. So now you take this 3, put it into that r right there. And we find that a sub 1 equals 5. So now I can write the rule. A sub n equals first term, which is 5, times 3 raised to the n minus 1 power. I'll go ahead and do b, but I'm going to let you know the answer to b is going to be a sub n equals 80 times 1/4 raised to the n minus 1 power. But you're going to do it the same way. Next thing we have here is a sum of finite geometric series. The key here is that r has got to be, cannot equal 1. That goes down there. So it's going to be s sub n equals a sub 1 times 1 minus r to the nth power times 1 minus r. Okay. Now that's if it's geometric, and you got to keep that in mind. Find a sum of geometric series. If I put 0 into this I, I'm going to have a 0, excuse me, if I put 1 into this I, that's going to be to the 0 power. And as you know, anything to 0 power is 1. The reason I bring that up is that the first term is 4. That's why I bring it up. Therefore, s sub 6 equals a sub 1, which is 4, times 1 minus 3 over 2 raised to the 6th power, all that minus, or excuse me, all that divided by 1 over, all that divided by 1 minus 3 halves. Put that in your calculator, and what you get, 665 divided by 8. This one's a little bit different. I'm starting off here at 0. So if I put 0 in there, that's going to be 5/4 to the negative first power, which is really 4/5. So a sub 0 equals 256 times 5/4 to the negative first power, which equals 204.8. That's really your first term. Now, if I'm going from 0 to 5, there's going to be 6 terms there. That's why I'm going to have a s sub 6, which means the first 6 terms. First term, 204.8. Times 1 minus 5/4 raised to the 6th power divided by 1 minus 5/4. Put that in your calculator and you get 2,305.8. Okay, in 1999, about 586,000 cars were sold in Maryland. From 1999 to 2004, the number of cars used cars sold increased by 3.8%, which, keep in mind, is going to be 0.038, which means R is going to equal 1.038. A sub n equals 586 times 1.038 raised to the n minus 1 power. How many cars were sold in 2002? N equals 4 in this case. A sub 4, 586 times 1.038 to the 3rd power, which is 655.375. Now keep in mind, it's in thousands, So that decimal point is really a comma. So 655,375. Now the follow-up question would be, how many cars were sold from 1999 to 2004? You just use this equation right here. All right. Let me know if you have any questions.